Good day, viewers. This is Ademola Johnson, your science tutor. We have started a series of topics in chemistry recently, that is beginning from electronic configuration of elements. And we have done 2 videos concerning this. The first one talked about general introduction of electronic configuration, then key element, then the other one is SPDF configuration, where we talked about orbitals. So this one, we want to look at laws that govern or guide electronic configuration. There are 4 basic laws, that guide, that govern the arrangement of electrons in the atom of the element. These laws are, the first one is called Heisenberg Uncertainty principle. Heisenberg Uncertainty principle. Number 2 is Aufbau principle. Number 3 is Hund's rule of maximum multiplicity. And lastly, number 4 is Pauli exclusions principle. So we are going to take them one after the other to talk about them. So we may not be able to exhaust more than 1 or 2 of them in a video. Then the subsequent video we continue to carry them. So, but we'll try to see how much we can do as time will permit us. Now, let's look at the first one, Heisenberg Uncertainty principle. Now, I want you to know here, this principle was postulated. It was postulated as Heisenberg by Werner Heisenberg in 1927. It was postulated by Werner Heisenberg in 1927. And what did he say? It states that both the position and the momentum of an electron of an atom cannot be known with certainty. It's not possible to know both the position of an electron and still know the momentum of that electron. So you're already aware that when we're talking about momentum, we are talking about the product of the mass and the velocity of the electron. So velocity means the speed. Even though there was a man called R.A. Millikan. R.A. Millikan carried out oil drop experiments, and he was able to determine the mass of electron as 9.1 times 10 to the power minus 31 kilogram. We are able to know the mass, but nobody using that mass. You can't know the speed, the velocity at which the electron is moving. If you have been able to know that, it's just to multiply the mass by the velocity, but it's not possible to know that. No, we have not been able to determine that. So, and from the fact that it is also possible that electrons can move from a permitted energy level to another permitted energy level, moving from ground state to excited state. So nobody can determine the position of what? Of electron with certainty. And that is why it is difficult for us to determine the bond angle in a molecule, and as well the bond length in a molecule with certainty. That is what Heisenberg Uncertainty principle is talking about. Now, let's go and look at Aufbau principle. You can see that I did not say Aufbaus, I did not put apostrophe S, because Aufbau is not the name of a scientist, it's not the name of a person. It means arrangement. So we can as well call Aufbau principle arrangement principle. We can call Aufbau principle arrangement principle. What did this principle state? Now, the principle states that this states that while building up an atom with electrons, when you are trying to build up an atom with electrons, electrons are first fully filled into orbitals with lower energy level before filling orbitals with higher energy level. What is it saying? This principle is synonymous to what happens in the family. In a given family, let's say a family, a father, a mother, and a child, they go for a vacation, and on getting there, the available food is not enough, or a food is given. The normal law of the family is that the child has the lowest energy level, the father has the highest energy level, the mother has an energy level that is not up to the father but higher than that of the child. In that case, Aufbau says what? You must first of all make sure that that child, which has the lowest energy level, to first of all eat the food and get satisfied, and after which the remnants can be passed to the mother. Then if the mother eats and gets satisfied, if there is no food again, the father will not eat. But if there is remnants, then the father feeds from the remnant. So the last born feed first, followed by the mother, then followed by the father. So now, the same thing is applicable in chemistry. When you are building up an atom with electrons, you have to put electrons into orbitals with lower energy level first. Go then to the orbital with higher energy level. Now, we can also say this principle also states that while building up an atom with electrons, now no orbitals with lower energy level must be left vacant while filling orbitals with higher energy level. Let me leave the board so that you can see what I'm talking about here. Now, no orbital with lower energy level must be left vacant, while you will now go and fill orbitals with higher energy level. No. But with this principle, a lot of questions have been asked. Okay, can you try to help us arrange orbitals in increasing order of energy level? And scientists have responded that there are two methods of arranging orbitals in increasing order of energy level. Let's go and see what I'm talking about here. Now, orbitals are arranged in increasing order of energy level following the following two methods, which are, there are two methods. Number one, construction of orbital triangle. Number two, now, through the knowledge of the carrying capacity of atomic shells with orbitals. We have done this one in the previous video, in the part 2 of this series. That is the relationship between atomic shells and orbital. You can go to my YouTube channel, Heisenberg Johnson, and watch that video. Now, let's look at what I'm talking about. Let's take the first one and talk about it. Yes, the first method now, orbital triangle. Orbital triangle. The orbital triangle is constructed as follows. You know, don't forget we are dealing with S, P, D, and F. We are using this notation. So we start with 1S. Next is what? 2S. Then 2P. The first one is S, which is this. Because it is starting, we put 1. Second one is 2S, 2P. Now we are proceeding to 3S, 3P, 3D. 3S, 3P, 3D. Then the next one will now be 4S, 4P, 4D, and 4F. That's S, P, D, F. Then the next one now, since we don't have any other notation, we now start reducing it. 5S, 5P, 5D. We will not proceed to 5F. Then we go to 6S and 6P. And lastly, we have 7S. We have constructed a triangle called orbital triangle. With this orbital triangle, we'll now begin to introduce an arrow. And mind you, while using the arrow, a particular arrow will pick the same number of points 2 times before progressing to the next one. You put the first arrow here, it picks only 1 point the first time. Now you are putting another arrow, it's picking only 1 point. So it's doing that 2 times. Then the next arrow will pick 2 points the first time and still pick 2 points the second time. Then the third one is picking 3 points the first time and picking 3 points the second time. Then the last number we have here is now going to what? Picking 4 numbers. Now, from the above diagram, orbitals are arranged in increasing order of energy level as follow. Now, we will now go to the first arrow. What do we have there? 1s. Go to the second arrow, you have 2s. Go to the third one, you have 2 points. When you have 2 points, start from the bottom of the arrow. We have 2p. Then you have 3s. Then come here, you have 3p and what? 4s. Then come to this place, we have 3d, we have 4p, we have 5s, and so on and so forth. Now, but I want to tell you this. Why I don't like this method is that the thing must be rearranged. What do I mean? Let's go to the second. Before we go to the second, look at this. Now, the arrangement now is modified as follows. We see 1s, 2s, 2p, 3s, 3p, then we have 4s. Instead of 4s, 3d, we write 3d first. That's the arrangement. 3d before 4s. Why? I will explain. Now, this is because 4s orbital has a higher energy level than the 3d orbital. What do I mean? I think you have followed the previous one. How can 4 come? Look at the arrangement. 1 first, progressing to 2 and 2. Next one is 3 and 3. You cannot have 4 and still come back to have 3. It's not possible. So all the 3 will be pushed to one side, and all the 4 will be put to one side before we come to 5. So, because even in arithmetic, in mathematics, it's not possible for 3 to have higher energy level than 4. So, if we write it like this, you are telling us that 3d orbital has a higher energy level than 4s orbital. It's wrong. So, let's look at the second method now. Now, second method is what? Considering the carrying capacity. The carrying capacity. Considering the carrying capacity of atomic shells. The carrying capacity of atomic shells. We want to consider that. Now, we want to consider the carrying capacity of atomic shell. Okay, let me take away this part. In the previous video, you can please go and watch where we talked about the relationship between orbitals and shell. You know, we have n, which means principal quantum number. We have shell, and we have orbital present in the shell. The principal quantum number for K shell, first one is K shell, is 1. And I told you that K shell contains S orbital. Is that so? Then the other one is number 2, L shell. L shell contains S orbital and P orbital. Number 3 is M shell. KLM, okay, M shell. And this one contains what? S orbital, P orbital, and D orbital. Then the last one is N shell. N shell contains S orbital, P orbital, D orbital, and F orbital. Now, we are not done yet. With this, then let's apply the right coefficient to these values. The principal quantum number for K shell is 1. So everything pertaining to it, we put 1. The principal quantum number for L shell is 2. So anything pertaining to it, we put 2 here, we put 2 here. Then the principal quantum number for M shell is 3. So everything pertaining to it, we put 3 here, put 3 here, and put 3 here. Then the principal quantum number for N shell is 4. So we put 4, 4, 4, and 4. So if you look at this arrangement now, you will see that you have 1s, which is this. You have 2s, which is this. You have 2p, which is this. You have 3s, which is this. You have 3p, which is this. Then we have 3d. That arrangement has automatically been made. You have 3d before you now have 4s. So that is that. And like that, it continues. So you have 1s, 2s. So you need to go and memorize this arrangement. Because I've seen questions where they ask, which of the following is the correct arrangement of orbitals in increasing energy level? We have 1s, 2s, 2p, 3s, 3p, 3d, and 4s. 1s, 2s, 2p, 3s, 3p, 3d, and 4s. So you need to memorize this one before you watch the next video, where we are going to look at application of Aufbau principle in writing the electronic SPDF electronic configuration of elements. See you there. Like this video, share it, go to my YouTube channel titled Afe Ademola Johnson and watch as many videos that will benefit you academically as possible in the field of sciences. I remain my humble self, Afe Ademola Johnson. God bless you and bye for now.